just change the unit from the kilonewton to meter. Now I will say file, new project. So it is start with the new project now. First of all, if you see, the entire thing is blank. Now I wanted to generate the model. For the generation of the model, I required the grid line or else nodes. So you can generate the grid line also by using the structure grids, define point grid and the line grid. You can define in this way, or else you can directly start the modeling by using the nodes element. Just right click on a screen. So whatever the command you are seeing in the right click, the same thing is appear here. If you see nodes and element, node create node to the node table. Same thing, right click node, create node to node table. So entire commands are available. If you go through the GUI, if you right click on a screen, then also you can see. So I will just generate the nodes, create nodes. First is coordinate 0, 0, 0. So I will start from the 0, 0 coordinate. I just say apply. Now once I say apply, close. This is the select single, means for the normal for the selecting the single point. I just select this one, and now you can see this box. One node is selected. Even it is highlighted node number. So these two options are available. This is for the node number. This is for the element number. Now from the one node, I wanted to generate the other node. So I just select the first node. Then I will just right click nodes and I will say translate. Now what is the meaning of translate is, here we have the two options, copy and the move. So in the translate command you can do the copy as well as the move also. Right now I'm doing the copy. Just say it's 10 times number of times, my distance is 4 meter and number of time is 10, and I will say apply. Now you can see all this my nodes in the X direction it is generated. Similarly, this is the one dot option, display the node, or else you can click on the display option. This is the display option, say node and the node number, and if I say OK, now in the screen you can see the node numbering. If by mistake in the some particular point, if you are getting the error, so how you can identify in the program? So that is, we have this option. Just come to this option, and if you are getting the error in the number 5 node number, just type the 5 and enter. Now you can see the program will automatically identify which node, where that particular node number will come. So it is easy to identify the errors. Generally in the, if you see in the EDM, so it will give the X, Y and Z coordinate, but here it will give the node numbering. You can just type the node number in the box, and the program will automatically identify where the exactly that particular node will appear. So it will, you can directly show. Okay, now next is, similarly I just use this option, select all, and I will select and I will generate it for the other side, means in the Y direction. The same option I will use, but right now I'm using the equal distance, but now I wanted to use the unequal distance, so I can use the unequal distance Y direction. My first dimension is 4 meter, sorry, 6 meter, comma, my next dimension is 3 meter, comma, again my next dimension is 6 meter. So in this way also I can define the dimension and just say apply. Now you can see, if I just click here, we have, according to the same AutoCAD, we have this option, top view, right side, left side, back side, ele elevation view. So various options are available. I will just say top view. Now this is the, my top view is generated. So in this way you can see 6, 7, 8, 9, 10. So my 10 options, 10 grids are generated. Okay, so in this way we can do the, we can start our the modeling. So now this is the my column points. Okay. Yeah. So I wanted to go for the next is draw the my beams and the column. So for the draw the beams and column, we require the properties. So we can go to the properties here and just say material property. Okay. And just say add. Now in the add, I will say first is asking the type of the design. So right now we are doing the concrete structure. So I will say here concrete. and the standard I will use the American code. Over there, which code you are using, sir?
ACI. ACI.
ACI. Okay. Okay, fine. Yeah. Okay. So I'm clicking on the ASTM, that is the American
Mm-hmm.
code, and then from the database it will ask whether the M25, 30, 35, 40. So based on the all up to the 25 to 100, we have the grade. We can select the any grade. And right now I'm selecting the M40 grade. Based on that, modulus of elasticity, Poisson ratio, thermal coefficient, entire value will calculate it. If you change the grade from 40 to 50, you can see modulus of elasticity value will change. So based on the formula, it will automatically calculate. If you want to define your own value, then in the standard, you have to click as a none, and now you can define your own value because you are not going according to the code, so you can define your own values. Now I will just say ASTM, just say M40 grade, and I will say apply. If I say apply, the still that box is open, so I can select the second one properties also. I will say grade 30, say OK. If I say OK, now the box will close. So to close the command, you have to say OK, and for the continuation, you can use the apply command. Now next is we have this option like section. In the section, I will just say add. Now in the add, first is the DB. DB means it's the database. Okay. So from the I section, now here you can see the various sections are available. Angle, channel, I section, T section, box, pipe, double angle. So various options are available. In these options, you can see first if I say angle and from the angle database, here it is asking the database. I will just say AISC, and according to the AISC in the section, you can see the database will directly appear. Okay, so generally for the L section, for the steel section, we are using this option. For the concrete section, you have to come here and you have to say solid rectangle. Click here, I will just say column, say 300 by 800, or else I can see only the C 300 by 800. Say user, this is my 300.3. The definition of the column is the same as in the E tab. For H is the X dimension and for D is the Y dimension. Just say apply. Then for the beam, I will just say 230 by 450. That is for the plinth beam I'm using. 450. Say 300 by 450, not the 230. Say apply. And then above I will use the 300 by 600. If you want, I will change the one column sizes also by C 300 by 600 I will take. Now at the time of the definition of the section, you can see we are not defining anywhere about the material property. Even we are not defining whether it is the beam or column. So it's based on that program will automatically take care. If you model as a vertical element, so it will consider uh, as a column, and if it is the horizontal member, then it is considered as a your what we can say the beam. If it is the inclined member, it will consider as a truss element. No need to go and means define it whether it is the beam or whether it is the column or this way. So this is program will identify according to the your modeling. Then I will just say okay. Now this is for the section property. Now I wanted to go for the wall thickness. So just go to the thickness and just say add. And here in plane and out of the plane thickness, I will just say 300 thickness. This is for the shear wall I'm using. Even for the flat slab also, you can mention here 0.3. Generally in ETAB, if you see the we define that the in membrane and in the plate element means the thickness. The same thing is here in plane and out of the plane. Both the where you have to define the same thickness. If you want the different thickness in the for the in plane calculation and out of the plane calculation, then you can use the second option. So both the options are available. Up to that, you have any doubt or something
Regarding the truss. Hello.
regarding? Yeah.
Yeah, the truss. If it's
truss
inclined,
element.
yeah, if
Okay,
it is inclined, it will automatically truss member.
take the truss element. No, no,
Yeah,
brace
so
element actually. It is considered the
breaks.
brace element. Yeah,
Okay.
but if you wanted to consider the truss action, then the element type you have to mention as a truss.
Okay, okay. Yeah, that's all.
Okay, so at the time of generation of element, I will show you. So which are the things are available.
Mm.
Okay, yeah. Now all these things are generated. Now I wanted to generate the column. So for everywhere my same column I'm using. So I will just select all the nodes. Now I wanted to do the column. So just right click on a screen, element, and you have to say extrude. Okay, now in the extrude command, it's asking node to line element. So program will what happen from the node, it will generate the line. Then my element type is beam. So because it will take the tension and the compression, both the things. That's why we said the beam element only. If you say tension or else compression, so it when the, if so according to that it will take. But if you say beam, so it will take the both the things. Then material is grade 40. My column is C 300 by 800. Even here the beta angle is there. If you want, you can give the angle. Then my height is 3 meter. And if I say apply, now my column is generated.
Okay.
Okay. Now once my column is generated, I just closed it. Now in the works menu, now you can see in the works menu, nodes. It is highlighted here. Element type, right now we are clicking on the only the beam elements, means all the line elements. So if these are here, now what are the things you can see in the blue color means that is you are defining, but still you are not using anywhere. And what are the things in the black color, that particular property you used means if I click on the grade C40, now you can see all the columns are selected. Even if I select the 300 by 800, all the things are selected. But if I use the 300 by 600, nothing is selected. Even the selection you can identify by using these two options. Here node selection, here is the element selection. So from the here also you can identify which are the something is selected or not.
Okay.
And this is for the unselect all. Now I wanted to draw the beams. Just right click on screen, element, and I will say create element. In the create element, the element type. Now this is the most important. If you set truss element, then according to the truss element, it will consider the your behavior. Similarly, whether it is the general beam, for the tapered beam you can use. Then axisymmetrical solid element, wall element. So according to that, you can use the element type. Right now I'm using the general beam to draw the beam. Once you click on the any one element, it will appear one box here and it will guide you which node you have to select it. You can see here N1 and then second you have to select N2. So in this way you have to select the nodes. Now my grade is here, you can see my grade is C30 and my section
Okay.
is 300 by 450. Now here you can see at the time of the modeling you have to define the which grade you want and the which thickness or the section you want. So here you have to define the grade and thickness. That's why we are saying we both the things are separately we have to define, and at the time of the modeling you have to club it. Okay. Now I click on the nodal connectivity. I click first node and the last node. Okay, and the first node and the last node here. Now you can see by using this option intersect, program will automatically break the element each and every nodes. No need to go and click at every joints. So
Yeah.
it will save your timing.
Yes.
Okay, now I select all these elements. Okay, all my these elements are selected. Now I wanted in this y direction. So what I will do, just right click element and I will say translate. Now in the translate, copy unequal distance y and I want 6 comma 3 comma 6. Say apply. Now you can see everything is copy here. Same way, this vertical beam I am selecting, say equal distance 4 meter 10 times, apply. Now my whole frame structure is generated, or you can see the one my level is generated. Now I wanted to change some size or something. What I will do after the modeling? So you have to select. I just show you. So just select this beam. Actually, this is the 300 by 300 by 450 beam. Now I wanted to change it to the 300 by 600. Just select the element and come to the trim menu, and from this selection, just 300 by 600, just click and drag it to the screen. Now you can see the size is changed.
Mm-hmm. Mm.
Okay,
Okay.
I will show you again. Just select the element, and from the trim menu, select the property which section you wanted to assign. Just click and just drag to the screen. It will change the property.
Okay.
Okay.
Yeah.
Yeah, so for the beam, for the column, even for the wall, so for the any type of the section, if you want to change the properties, just select that property, and from the tree menu you can drag it to the screen. It will automatically change.
Mm-hmm.
Now one floor is generated. Now I wanted to generate the another floors. So I will just select all, go to the structure, and then control data, and I will say building generation. Now in the building generation, I will say number of copy 10, and the distance is 3 meter. Say add. Now at the time of the add, if you see here, three options are available. Copy node attribute. If I click on this dot dot option, so it will ask whether you wanted to copy the support, point spring support, diaphragm disconnect, general spring, local springs, even the nodal load, temperature load, specify load, nodal mass, something you define in that particular level. If you wanted to copy, it will copy. If you do not want, then you have to hide this option. Just say uncheck this box. So that program will not copy the rest of the things. Okay. Similarly, for the element attributes also we have this option, means if you do not want it to the beam and releases or beam load, if you do not want the something particular things, then just off this option. If it is tick, then entire thing is copied into the next level, means wherever you wanted to copy.
Okay.
Now I will just say apply. My whole structure is generated. Okay. Now I wanted to generate the second thing is change the first properties. Okay, so I will just select here 300 by 450. Now you can see entire thing is selected. Then I will go to the view, and here activities. We have this option active. Active means what happened? Whichever the member we selected, only those section you can see.
Mm.
That is, we can say source selection only. This option we have in the tab also. The same thing command is here. It is called active or activate. Just right click, and the here also activities we have this option active. And each and every command you can see the shortcut keys also. Once you start using, you can see, you follow the shortcut keys also. Now I will select the above all the beams, and from the tree menu 300 by 600 and drag it to the screen. Now my all the above beams are 300 by 600, and below is 300 by 450. Say activate all, and now particularly above three levels, I just select the columns, four levels, sorry. I will give the property 300 by 600. Just drag it to the screen. Now for the difference I will show you.
Yes.
Yeah, now you can see here the below column is 300 by 800 and the above column is 300 by 600.
Okay.
I just say activate all. Now you can see the entire thing. If you do not want to see these nodes, just click on the display option and just off this node function so that you cannot see the nodes. Now entire thing is there. Okay. Now one more thing is, if you click on the top view, so this is the top view, but this is for the all story. It is not that you are working on the one floor. If you I select this particular beam, this one, okay, I just delete one row actually. Yeah, I just select this one, these two, this one, and this one. I I just say activate. Now you can see if I select it from the top view, but the entire thing is selected. So be careful whenever using these options.
Mm.
Now I wanted to generate the shear wall. So I just select one, two, three beams, right click on screen, element, and I will say extrude. Now in the extrude command, we have this option line to planar element. Line to planar element means what happened from the line you can generate the slab, wall or anything in the any direction, not even in the Z direction, means here X direction, Y direction, Z direction, based on that you can generate. When it help you to generate the cantilever slab also. Now I come to the element type is the element type you have to consider wall element because we wanted to generate the wall, and here the source is removed. Source is removed means what happened, the the extension means from the beam we generate the wall, so that particular beam is automatically deleted. No need to go and manually delete, the program will automatically delete once we generate the wall element. Then my grade is 40, thickness is 300. Now my type is membrane or the plate. If I say membrane element, then what happen? It will take only the in-plane movement. So we want the out of the plane movement also. So you have to click on the plate, means the my subtype is plate and my main element type is wall. Okay, and this is the wall ID, means it is the kind of the peer label. We can modify the later on. And my height is I am saying -3 and apply. Now you can see everywhere it is generated. Okay. Now one more thing is, now I wanted to do one thing here. I just select this particular node, right click, node, sorry, both the this one. I just select both the end, right click nodes, and I will say translate. Translate, and I will say equal, it's a 2 meter, and I will say here intersect the frame element and just say apply. Now if I say here, now you can see here node is generated, and because of that reason the element is divided. Okay, so here I wanted to the E-shape shear wall. So we can generate the E-shape shear wall that I'm just going to show you. Just click this two box, X is to 0, apply. Okay, now you can see here I just generate the one more thing here. Just generate the one beam. So it will help us to generation of the shear wall. Any grade it is okay. Yeah. Now I will just select the this one and this one. Okay. Right click, element, and just say extrude again. In the extrude, line to planar element, say it's a wall, grade 40, 30 plate. Here it is -3, and just say apply. Now my shear wall is generated, but only thing is here. So I'm using here these two as a 300 by 450 beam, and the same way I'm just selecting these two and this one beam and copied into the below levels, because if you see here in the below level, right click, element, and I will just say translate, copy, -3, 9 times, apply. Okay. Oh, it is one more. Okay, so this 3 -3 one time and apply. Yeah. Now entire thing is generated, but only the thing is if you see here, I just go to the display option, and in the display option element, and I just say wall ID, display option, element, and the wall ID. wall ID. Wall ID means it is the peer level we can see. So each and every rectangular wall we have to give the different peer level. So how we can define the peer level is come to the nodes and element and just say change parameter. See change parameter. Here also you can define, you can use here this option as a assign also. So you can change the material grade, section, thickness, wall IDs. Even you can change the element type also. Means if you model the beam element, but you wanted to change it to the truss element. So most of the time what happen? You have to delete it and again you have to regenerate it. But here you can change the element type also. Means if I say initially I model beam, but I want as a truss element, so I can change it from to. So anytime I can change these properties. Now I just say wall ID. This is my section 1 and auto increment. If I say 1 apply, so automatically second time it will take the second next number. Just select and assign. So now it is done. 4, 5, 6, 7 and 1, 2 and 3. And if I say the activate all, this is entire the geometry generated just of the wall ID. So this is about the normal our beam column and this one. Now one more thing is remaining is in the nearby the shear wall. If you see there is some columns are there. Generally, if you model the shear wall, we doesn't require the columns, the vertical columns. So we can delete it. So just select this window, this one. Okay, now this one and just say right click element and you have to say delete. Don't direct use the delete button. If you delete it, then connecting nodes also deleted and the particular node which are the elements are connect, the entire thing is will be deleted. So use only the elements delete option. Just select with the free nodes apply. So it will automatically delete it. Now two things we have to do. One is about the generation of the floors, because right now we are generating only the model, but if we where we wanted to want the your floors or where we wanted to consider the diaphragm, that we have to define it. So we will define these things. So before that, first of all, we define the support condition. So for the support condition, the boundary we have to click on the define support. So for the define support, if you see we have to select the first bottom nodes. Then we have this one good option, that is the select by plane. Now in the select by plane, what happen if I click this option XY, and if I select anywhere in any Z point, it will automatically take care of XY elements. If I say activate, you can see it will show you the only the XY plan. Again, I say activate all, you can see the entire thing. Similarly, if I say XZ and if I click on this particular node, so what happens, the program will select this X and the vertical is Z and just say activate, you can see the entire thing. Similarly, if I say activate all, the entire thing we can see again YZ, and same point if I'm clicking, the program will select the Y plane and the vertical is Z and activate. So it will in one click you can generate your own elevation view. No need to generate the grid, so that for the generation of the elevation view, in one click you can generate. Even one more option is okay, so these options are available. Right now I'm clicking on the XY and just click the bottom nodes. All my bottom node is selected, and then right click boundaries and support. In the boundaries support, I will select the D all, that is the translation, R for the rotation, and just say apply. All my node I am selecting, that is the done. So entire thing is done now, means support conditions are fixed. Second thing is, come to this option. Now you can see everything is from the center to center actually. If you see the beams also, entire thing is set from the center, but generally we require the beam to be flush from the top. So what we can do is we can go to the structure, say structure type, and here you have to define two things. One is the convert sulfate into the masses. for the conversion of the mass. So it will help you to calculation in the seismic analysis. And then click these two options, align top of the beam section and align the top of the slab. If you model the slab, so for this reason, otherwise align the top of the beam. And if I say OK,
Okay.
now I will zoom it. Now you can see
Yes.
it will automatically flushed it. No need to go each and every point and it will go and calculate. Okay, the program will automatically calculate it. Now second thing is come to the control data and you have to say story. Okay, in the story, here is the ground level. If you click here, you can define your ground level also, means anywhere uh, in the any plan if you wanted to define the ground level, so that in the below level it will not consider the your lateral load. From that above it will calculate the lateral load. So you can define the ground level, otherwise it will calculate from the base. Now here you have to click on the auto generate story data. Just click according to the Z coordinate, it will take the entire thing. So whichever the level you wanted to consider for the diaphragm, you can select. Otherwise, if you do not want, just click here and just unselect it. If you unselect it, that particular level will not consider for the diaphragm. And the second thing is include the seismic accidental eccentricity, that is the 5% of plant dimension. For the wind is the 15% of the plant dimension. So it is eccentricity, it is mentioned here. I just say OK. Now you can see here it is coming, the floor diaphragm is consider means what happened, it is the rigid diaphragm. If you click here and if you say do not consider, then it is the flexible diaphragm. So these two options are mentioned according to this. If I say wind, so this is my floor x and y dimension, what is my center, that is the diaphragm center, you can see, and the eccentricity mention the values are here. Even the seismic also, if you want you can change the values in this box also. It is this box also you can change. And then I will just say close. Now my this thing is generated. If I click here, just go to the boundary, and the last option we have the story diaphragm. If I say OK, now you can see the my all the connected diaphragm. So it at each and every at the center, you can see. Again I will select this one, boundary, and the story diaphragm just off. Okay, and this thing is done. Now I just click on this option, check duplicate element. There is a nothing, and check the free edges. So you can see only the periphery it will show, means there is only the free edge at the periphery, not at the intermediate. So it is connected through and through. And then go to the boundary. In the boundary we have the beam and releases. If you want, you can select the some beams for the secondary beams, or if you wanted to release for that particular end, you can select in, and you can delete, you can give the beam and releases for I node and the J node. And you have to click on this option, panel zone effect. So this is the one more option, that is for the calculation of the movement from the face of the member. Just click on the panel zone effect and click the auto calculate panel zone offset distance and just say OK. So for the calculation, program will take the movement from the face of the members. It will not calculate from the center, it will take from the face. So up to this is our the modeling part is over. Now next part will start, that is the loading part. So before that I just wanted to know the means if you have any doubt regarding the modeling and these things.
No, it's okay. Go ahead.
Okay, yeah.
Yeah.
Now the next thing is we have to define the load. So before defining the load, we have to define the which type of the load cases you wanted to define. So now from this I will just say static loads, static load cases. So here first is sulfate, and my type is dead add SIDL, that is the superimposed dead load. So in this that particular load case I will define my floor finish, my brick wall load. So these are the things I am defining in the this particular case.
Okay.
Then I will decide LL, that is the live load. My type is live load add, then wind 1, and my load type is wind load on structure. Similarly we have the 12 load cases, so we have to generate it according to that.
Yeah, nothing 30.
These are the only the name we are defining. Then I will just say QX, earthquake X, say earthquake, apply. Similarly, earthquake Y, apply. So now I just say close. Now similarly, you can see in the works menu, all the my load cases and these things are generated. Earthquake X, wind my 12 cases, live load SIDL, these things. But there is a nothing will come, so that only we are defining the load case, but we are not assigning anything in that particular loads. Now second thing is click on this option self-fed. So in the self-fed, we have to mention in the which load case you wanted to calculate the self-fed. Means program will automatically calculate, but in the which case you want. So you have to define it. So I will say SW and my Z is -1 and just say add. Generally the same thing is available in the ETAB also. If you see the self-fed multiplier. So generally at the time of the static load cases, we are say that dead load self-fed multiplier is 1. The same thing is here. Here you have to say self-fed multiplier, that is the Z is -1 because of the gravity direction. Here everything is in the minus direction we have to mention. Now you can see here SWKC generated. Now next is load to masses. Load to masses means it is the, you can say it's a mass source in the ETAB. Generally we are defining the how much the percentage we are considering for the calculation of the seismic weight. So here I will just say SW is 1, SIDR is 1, and my LL is the 0.25. Say add, say OK. Now this one is also generated. Okay, now second thing is we have to define the loading. Now in the loading, first we define the beam loading. So I will just select the sections, that is the beam 30 and this one. Say select, say activate. And in the plinth level, in this level, I will select this particular beam. Everywhere I'm using the right now for the same beam property, the loading. I just select this one. Just go to the beam load and just say element. Now in the element, it is asking the load case. I will just say SIDL, say replace. Now it is asking the uniform load type, that is the uniform load, concentrated force, concentrated movement, uniform movement and torsion, trapezoidal load, trapezoidal movement torsion, uniform pressure, trapezoidal pressure. So various options are available. Right now we are using the uniform load, that is the UDL. Just click here and I will say here -10. Say apply. Now you can see here it is selected. Similarly, this particular bottom level, here I am defining the 12, apply, and this at the top level, only at the periphery I am using the load for the partition wall load, you can say -5 and apply. Now you can see here in the SIDL it is coming the element beam load. If you want to see the value, just right click on the trim menu here and just say display. Now you can see the values. If you want to modify value, you can select the element, go to this element and again select the case and just say replace and put. Otherwise you can do the one thing also, just right click here and just say table, and in the table you can change the load case as well as you can change the value. Here is the values there, P1 and P2, that is the start point and the second point, last point. So here you can change the values. You can export to the Excel also. Again, you can work on Excel and you can paste it back to the this sheet also. So these things are also available. Just right click and display and all. Okay, now next thing is in the beam load we have this option typical. Typical means what happened? The UDL, two triangular, single triangular, three triangular, trapezoidal, so for trapezoidal. So this type of the options are available. You can directly assign this type of the loading to the connecting beams or any type of the beams. No need to go and calculate the each and everything. You can directly assign this type of the loads. Pressure load, this option is available if you model the any slab. Right now we are not modeling the slab. So if you model the slab, so that is the based on the finite element base. So for that particular slab, you have to define the pressure load, and the pressure load option is used at the time of the designing the FEM, the particular FEM slab. It will transfer from the one slab to the another slab, means at the nearby the nodes, and according to that it will design. But whenever you model the slab, only that time you can use the pressure load option. Then second is the hydrostatic pressure. This hydrostatic pressure is, if you model the any retaining wall, then you have to model the retaining wall, just select that particular wall, and then here you have to define the two things. One is the reference height, means top of the your retaining wall height. You just select, just go and of this one screen or in the structure and just click on the top, so you can, it is automatically take care of the height. Then constant intensity means what happen, it is the surcharge load. So that in the surcharge loading, the program will automatically take the surcharge load. And the gradient intensity G value, it is the value which is calculated based on the your active pressure and the soil density, means K into soil density. You have to put this value, and the height will automatically take care based on the your selection and the reference level. So according to that, program will calculate the height. It will multiply with the gradient intensity, that is the my Ka value into soil factor and the soil density, and it will give the total pressure. So these options are available.
Okay.
Now next is assign floor load. Assign floor load, this option is available whenever the yield line theory, means your one-way, two-way slab is coming, or else you can say membrane slab. So at the time of no need to model the slab, you can directly assign the loading that particular periphery of the beams. So how we can define that, I will show you. So first of all, define floor load type. Here you have to define the loading grouping, means I will say here, say typical. My self-height of the slab, I will just say minus 2.5, that is the 100 mm thickness I'm considering right now. Then SIDL, I will say it's a minus 2, and the lie load I'm considering the minus 2. Just say add. Similarly here I will say roof, SW is here, SIDL is 3.25. Sorry, here I will say it's 3.25, and my SIDL I'm considering 2.5, and my lie load I'm considering the 1.5. Say add. So typical and the roof, these two type of the loadings are done. Now 1, 2, 3, 4, 5, 6, 7, 8. Okay. I will just select the any one level. So this one level below is the plinth level, so no need to define the loading. I just select this one. Now from this level, I wanted to define the loading. So what I will do is I just go to the assign floor load type, floor loads, say typical. Now you have distribution. It will ask the one-way, two-way loading. Right now I will show for the one-way loading. Just click on the one-way. Just click here. First node, second, third, fourth, and the last one. You can see the program will transfer the loading in these two directions. Here the angle is there. You can change the angle anytime. Second thing is two-way loading. Same way, you have to click first, second, third, fourth, the last option. The program will automatically identify the shortest span, the triangular loading, longest span, the trapezoidal loading. For the better, this one I can select this one. Now you can see here, in this area the program will transfer the triangular loading, and the other area is transfer the trapezoidal loading. Similarly, we have one more option, that is the polygon centroid. Generally, irregular slabs is there. The what happens, the program will calculate the CG and transfer the triangular loading to the connecting beam. Otherwise, we have another option, that is the polygon length. The total load divided by area, and it will transfer the UDL to the periphery beams. So this option is also available. These two options are available, polygon centered and the polygon length. These two options also you can use for the transferring the loading. Okay, now we'll start. We can define the loading for the entire area. So I will just select here typical, say two-way loading, and here one more option is available, that is the unmodeled sub-beam. Means if any hidden beams are there, so without modeling that hidden beam, you can take the loading, means point load into the your the main beams. So this option is also available. Just a copy floor load, and here I will say three. Sorry, my 8 times 3 meter is the my distance, 3.0 meter is my distance, 8 is the numbers, means 8 times I wanted to copy from these to these levels. I just click here, first, second, this one and this one. Now you can see here, activate all. So entire thing you can see. Now again I will just select the top value, this one, top one. Say a roof, click here first. Now here you can see there is nothing will happen because we click on the 8 at the rate 3, because at that above there is a no floor. So you have to just off, again click here. And whenever you are applying the this type of the loading, always work on the XY plan or else 3D plan, so that you can identify easily the all the nodes. Otherwise, if the column is also on, then program will cannot detect the which node you are selecting, so it will give the error. So use these options. Now you can see here program will automatically identify this area how the loadings are done. So this is the things. Yeah. Now my floor loading is done. Now my next step is about the lateral loading. Now I come to the lateral loading. First is the wind load. Say add. Now one more thing I just wanted to tell you, that in the MIDAS the it will not generate the automatic 12 load cases right now. You have to manually generate it. Once you generate it in in the one project, the same thing you can copy into the next project also. No need to again generate the entire your load cases. You can copy paste also from the your existing MIDAS file. So it is the only the one time you can say the definition you have to do, or one time the load case definition is there. Now I will say just add, say wind 1 W1, say ASC 710, directional procedure and alternative method. Two methods are available. So alternative method is based on the leeward and the windward, and directional procedure is depend upon the value you are saying. Here I will say it's 100. Exposure category C, min roof height 33, it is calculated based on the dimension we define. Then whether it is a rigid structure or flexible structure. So if it is the rigid structure, then gust factor is calculated based on the your XY dimension and exposure category. And if you say calculate, the program will automatically calculate it. If you say the flexible structure, and if you click here, so natural frequency X and the Y direction you have to mention, and the damping ratio also. Again for the natural frequency, again you have to first run for the dynamic analysis and check the your X and the Y frequency, and again you have to put it here. So these are the things are available, or else you can directly define it, then you have to say calculate. So direct calculator is also available. The wind eccentricity, initially I will say X direction 1, here it's 0. And if I come to the wind load profile, now we can see this is the profile, story force, this is the story shear. Each and every floor you can see the pressure, loaded height, loaded breadth, wind force, and the story force and entire thing. Similarly, if I click on the make wind load calculation sheet, here it shows the formula, how the F is calculated, how the P is calculated, QZ, QH, entire thing. Even in the bottom, each and every floor it will give the entire values. You can use this for the documentation purpose. You can save this copy. You can use this for the submission purpose also. You can capture this graph also. This option is available. Now I will say apply. Now W1 is generated. Now W2 0 Y direction, apply. Now W3, so both the direction is 0.75, 0.75, apply. W4, it's a minus 0.75. Now it's a 0, positive, 6, X negative, 7, X is 0, y is 0.75, y is positive, it's negative, then 9 is 0.565, 0.565, x positive, both are positive, x in the y direction, apply, 10 is x is positive, y is negative, 11, y is positive, x is negative, and the 12, both are negative. Say okay. So these are the all the factors are defined in the ASC 710 code. So if you see in that they have the four cases according means four cases are there according to the four cases. First two cases generate the two sub cases, and the next two cases generate the four cases. So based on that positive negative you have to generate it. And then next is the seismic load. I will say add earthquake X. I will say here UBC, SC, 2B, importance factor 1. Now again the fundamental period, I just click on the period calculator. Based on that it will show the formula. So I will just select this third formula, that is for the general building. Just click, because here is defining the for the steel structure also and the for the RC structure also. So the designer has to decide which formula they want to use. Otherwise they can directly manually put the whole means directly time period value. Then my ductility factor, right now I'm considering here 4.5 and 4.5. My x is 1, y is 0, and both are none. If you want, you can consider the accidental eccentricity and inherent eccentricity. If I click on the seismic load profile, you can see this is the story force, story shear, overturning moment. Now in the story shear, again you can see the weight, each and every floor weight, seismic force, story force, and the story shear. If you click on the make seismic load calculation sheet, here you can see my CA, CV values, my the seismic coefficient value, total seismic weight. If I multiply, you can get the my total base shear value. Even each and every floor value also you can get it by using this table. This option is also available. Say apply. Again for Y, X is 0, Y is 1. Say okay. Okay. Now you can see here, I just open the, you can see now here each and every load cases something is coming. Now if I click here for the earthquake, right click and display, now you can see the values in the X direction, so that it is identify you in the which direction you are applying the load. And similarly for earthquake Y, display in this direction. So in the both the direction, you can define the load cases, and you can see by using the your tree menu. So this is about the lateral loading. So now next is about the dynamic load. Before going for the dynamic load, I wanted to know that if you have any doubt regarding the any type of the loading.
No, it's okay. Go ahead.
It's okay.
Yeah.
Okay. Now next is about the dynamic load. In the dynamic load is the RS function, that is the response spectrum function. I just click here, just say add, and here you have to say design spectrum. Say here UBC, SC, 2B, and just say OK. So it will generate the spectral data, that is the for the period versus the acceleration graph. And similarly here you have to click on the acceleration. Otherwise, if you do not click on the acceleration, then the 1 upon g value, according to that value you have to calculate the scale factor, because in the UBC there is no mention about the g values. So that's why if you see if you define the scale factor in the ETAB also, they are mentioned that IG by R something, the value you have to input. Same thing is here. No need to put this one. You just click on the acceleration value. Just say OK. Say close. Now just click on the RS load case. Say RX. My scale factor initially is 1. UBC. If you wanted to know about the combination control, just click here. Now you can see CQC method we are using. If you want to consider the accidental eccentricity, you can click this option. Otherwise, you can directly say add. Again, for RY direction, my angle I have to change to the 90-degree because in the Y direction, for X direction is 0 and for Y direction is 90-degree. Just say add. And similarly along that we have to mention the mode shape also. So click on the eigenvalue analysis control and just click on the raised vector, and here for the acceleration X I will just say phi, add, for Y phi, and my for Z is phi. So my total cases are 3 and total number of mode shape is 15. So it is mentioned here. Just say OK, close. Now if you see in the tree menu in the above, analysis value, eigenvalue analysis is mentioned, and the rest of the thing it is mentioned here. So everything it is mentioned in this software. Now we can go for the run analysis also. So up to this it is okay.
Yeah, it's good.
Okay, yeah. Now next is come to the analysis, and you have to just say perform analysis.
Mm-hmm.
Okay, so within a 3.12 second, you can see the entire model analysis is run. So it is very faster as compared to the other software. If you see, it means that's why you can, means if you wanted to modify something, you can easily modify,
Mm. Mm.
and you can again recheck your model. So now I come to the first about the result part. In the result part, first of all, according to the combination wise, we check the result. But again, for the spectrum data, to match the base shear with the earthquake force, we have
Mm.
to know the scale factor. So we have
Okay.
to divide the earthquake X versus the spectrum X and the earthquake Y versus spectrum Y. So again, we have the two method. One is unlock the model, change into the scale factor. Otherwise, you can directly consider into the load combination. So whichever the factor we are considering in the combination, it is multiply with the scale of factor. So if my scale factor is coming 2 and my load combination factor is 1, so 1 into 2, so it will give the value according to the two factors. So that I will explain you. So first of all, we have to check the reaction forces. Reaction, just say reaction force and moment. Say reaction force and moment, and just SW case, say FZ value and apply. Now in the below, you can see the values. You can see here 11560, this one values. Now if you want into the tabular format, just next to this dot dot option, just click here. It will ask the record button. I will just say, yeah, this one. And just say none, or else you can click on the OK button. If you go down, you can see here, this is my earthquake force 866.0, and this one is 866.083, and my RX is the 1898, and this one is 2073. So I will just click here and just say calculator, my 866.083 divided by 1898.512. Almost, sorry, almost 4.5 my factor is coming, and divided by 2073.87, 4.17, 4.5, 4.4 and 4.17 my factor is there. So I just come to the load combination, say concrete design, say auto generation. Now in the auto generation, I will just select here ACI 31811, and here I have to say the RX is 4.45, add, and for RY is 4.17. Say add,
Okay.
and I will say OK. If I say OK, now you can see here, yeah, here my 1.2 dead plus 1 RX plus 1 live load. 1 it is multiply with the 4.45, so it will consider the 4.45 factor. So it is directly multiply with the combination.
Oh.
So it's depending upon the design engineer. If they want to modify it into the cases, they can can modify. If they want into the load combination, they can change into the load combination also. Okay, so for
Okay.
the load cases, again they have to unlock the model, change the load case, and again run it and again check it, and they can use it into directly into the combination also.
Okay. Yeah, this is good. Uh,
Yeah. Now next, yeah,
can we continue again next time?
yeah, surely. Okay.
Yeah.
So I just show you the some only the result part, and in the
Yeah.
next time we can start the designing. Then only give me the 5 to 10 minutes. I will just
Okay.
this one. Okay.
Yeah.
So now the second thing is in the deformation, you can check the deform shape. So I will just say W1. So in the DX direction, animation, apply value.
Mm.
So in this way, you can see the animation. Always, and you can save that animation also. Next is about the deform in the forces. The forces, if you want to know the truss forces, beam diagram, I just click on the beam diagram. Say any one combination. Say my, say value for all direction. Just say apply. Now in the apply, you can see the everywhere the values. I just zoom it in the screen. And you can see this is the one value. Now if you want to know about the detail, just click on the quick view and just click the load case and just click the any one element. Now in this box you can see the detail these things. Now you can click anywhere and you can see the values. Okay, this is only
Mm.
for the component MY. Similarly, you can change the component. Otherwise, if you want in the detail format, just come to this option, beam element, and just say beam detail analysis. In the beam detail analysis, you have to click the combination and just select the any one element. In the backside, you can see displacement, shear force, and the bending moment diagram. If you click anywhere in the red box, it is for the user. So if you click anywhere, you can see the values.
Okay.
Okay, this is for the moment, and this is for the shear force. This is for the displacement. Similarly, in the section along the lengthwise, you can see the stresses for the van missile, maximum shear, principal max, principal minimum. So these are the
Mm.
stresses, the options are available. According to that, also you can see.
Mm-hmm.
Then in the forces wise, you can see the wall forces also. If I say wall diagram, CLCB1 MY MZ value apply. Now you can see here for the wall diagram, it will show like the same as the column diagram. Okay,
Okay.
in this way you can see the in plane and the out of the positive and the negative movements in the each and every floors, and in the detail also. Even if you want in the tabular format, to just click on this next to dot options, so you can
Mm-hmm.
see in the detail format. The next is come to the mode shape. So in the mode shape, I just click on the vibration mode shape. In the vibration mode shape, I will just click on this dot option. In this box one, you can see this is your period, this is your radian per frequencies, and the summation also you can see here. The summation will take here 6 mode shape. So if I see the my 6 mode shape in the x direction is 90, and for y direction also 90, the up to the 6 mode shape I can go. No need to
Mm.
define the 15 mode shape. I can reduce it or else I can keep it the same.
Okay.
And if you want to see the mode shapes, so you can just click on the multi modes, and I will just select any 5 to 4 to 8 multi mode shapes. In one window, you can see the various windows mode shapes.
Mm.
So you can identify how the building is behave. And the lastly is about the tables. Is just a 1 minute. Okay. Now in the result table, in the story, we have the various tables: story drift, story displacement, story mode shape, eccentricity, story shear force diagram, overturning movement. So if you click on the anywhere, you can see only for one command I will show, that is only for the story drift. This is the story drift. You have to select the cases. I just select the earthquake X and Y. Say OK. It will ask the factor CD factor according to the ACI. Importance factor is 1. Scale of factor is 1. Allowable ratio is 1. And just say OK. Now you can see here program will identify whether it is the detected or not. If it is detected, means I will just show you how it is detected. Now you can see here it is detected. So it is mentioned the NG means not good. So it will detect it. The program will automatically identify if it is not good. So these
Mhm.
options are available to check the your story drift. So up to the results part, we are just completed. So I will send you the recorded copy also. And
Yes.
for the next session, Mr. Arun will again tell you about for the next
Yeah.
session.
Can we do
Okay.
it next Friday?
Yeah, yeah, sure, sir. At the same time,
Uh, can we make it earlier? Uh,
earlier means what
8:30?
time?
Maybe 8 o'clock?
8:30, 8
8:30.
o'clock, 8:30.
Yeah, 8,
Okay,
8 or
8:30.
8:30.
8 is okay, no problem.
Yeah, yeah, it's okay for you. 8 o'clock. Okay, I will
Yeah,
try
yeah, okay,
to
fine,
make
sir.
it.
Okay, okay. Mr.
We will
Arun
make
will
it.
send you the mail, or else if you wanted to change the timing also, you can send me
Yeah.
the, we can talk on the Skype also.
Okay. Okay,
Okay.
thanks.
Yeah.
Thank you.
Thank you, sir.
Thank you
Yeah.
very much. Okay,
Thank
bye.
you, sir.